So now I think everybody is in. It's 10:24. Scripting in JMAG is a very popular topic, and I'm happy to be the host of this webinar. My name is Martin Michels, and I'm responsible for the Process Office in Frankfurt, Germany. The presenter today is Vladimir Semin, and so that you can also see the name. He is from the Institute for Digitalization and Electrical Drives, which is located at Heilbronn University of Applied Sciences. The topic we will talk about is exactly using JMAG Script Editor to model electrical windings of any configuration. First, Vladimir Semin will do his presentation, and at the end, you have the possibility to ask him questions. And please ask your questions in Zoom, in the Zoom chat, or in the question and answer function. So, regarding Vladimir Semin from the Institute for Digitalization and Electrical Drive from Heilbronn University of Applied Sciences, he has studied electrical engineering with a focus on electrical machines at the Moscow Power Engineering Institute, graduating with a master's degree in 2015 and power electronics at the Technical University of Ilmenau in Germany as part of an academic exchange program, receiving his master's there in 2015. Between 2012 and 2019, he has worked in the space industry in Russia, in the town of Roscosmos. Since 2020, he is employed at the Heilbronn University of Applied Sciences as a research assistant, where he is also working on his PhD thesis. So I give the ball to Vladimir Semin.
Yeah, thanks, Mr. Michels. I like to welcome you all to my presentation. I'm trying to share my screen right now. Okay. It must work now, I think.
Yes, I can see the screen.
I would like to welcome you to my presentation with the topic using JMAG Script Editor to model electrical windings of any configuration. Firstly, I'd like to address a problem or an issue that I found in my time using JMAG Designer. I used JMAG Designer mostly for simulating and designing of electrical motors or electrical machines in general. And during this evaluation of different motor topologies or motor geometries, I had to try many different winding configurations. so that I could find an optimal winding for a given application. So a JMAG designer has several different ways to create models of electrical conductors, such as copper in slots of an electrical motor, for example. But when one has to conduct many different experiments, different simulations with many different winding configurations, it often takes quite a lot of time to set winding configurations every time when the winding configuration is changed. For example, the existing ways to implement a winding require a renewed setting of these winding conditions after, for example, a geometry change, like, for example, varying a slope number. When the slope number is different, in that case, the geometry is no longer the same, and the conditions that we have set for our winding are either gone completely or are no more correct. To solve this problem or this issue, I propose or try to use JMAG user scripts to solve this problem. Firstly, I'd like to address various ways that current or an electrical winding can be simulated in JMAG Designer. Firstly, one can assign a current or a current density as a condition and apply it to a certain part, like, for example, a copper conductor in a slot. Second way is creating a FAM coil, creating an electrical circuit model, and assigning FAM coils to parts. And the last option, of which I know first, is using the winding feature, where one can set regions on and generate a certain winding that is supported by the given pole pairs number and slope number. Every one of these possibilities has advantages and disadvantages. Like I said before, the last two must have an electrical circuit model, which is probably not ideal for when one tries to simulate something quickly to evaluate an effect on, in that case, a current density condition would suffice. But in this current density condition or current condition, it isn't possible to change the number of windings. I mean, windings like in a turns. Every time it is only one winding which is assigned to a part, which makes it impossible to simulate back EMF, for example, or to yeah, right. The method with FAM coils has no resistance calculation. The resistance has to be set by the user, and the winding feature or the winding function is the most flexible one of the three. One can not only assign link the electrical model and magnetical model together. It is also possible to generate existing windings automatically. And again, I'd like to mention an issue that I had with all these functions is that it takes a relatively long time to set all the conditions. For example, here in the last case, firstly, a circuit has to be created, an electrical model, then the regions has to be set, then the winding has to be set, and when it is our goal to investigate different windings or winding system on our design, our geometry, it makes sense to automate the whole process and automate the assigning or setting of any given winding which one would like to simulate. For this goal, it is possible to implement a JMAG user script, an integrated script editor in JMAG Designer or in JMAG in general, which would take this tedious work or automate this tedious work and save a lot of time. Such a script should import the winding data or the winding parameters from an external software or from a text file or yeah. Also, I mean, the winding parameters have to be saved somewhere, either saved somewhere or generated by an external software. The new winding should be applied either to an existing geometry or a geometry which was generated from a geometry template which was previously saved. In the script I have implemented the method of simulating a winding with a FAM coil. That means that a circuit has to be created automatically, and FAM coils from the circuit has to be linked to the FM coils and parts in the model. Then the script has to define the angle with which phase currents of the stator, for example, is shifted from the day axis of rotor, for example, so that the optimal torque could be achieved when we, for instance, would like to evaluate torque by a given generated by a given machine with different all possible winding configuration with the goal to find the best one or the optimal one. The script should be able to simulate numerous or a lot of different winding configuration in a loop, one after another, and export the results with our goal values that we would like to investigate. Like I said, a torque, for example, or the losses, electrical losses. Apart from that, it should be possible to generate a winding with any slot number, with any pole pair number, or a phase number of phases. To generate an initial data, the parameters, like I said, the pole pair number, or the phase number. I found used a software tools which called SWOT EM, and which is a free tool and can generate all possible existing windings with a given number of poles or phases or slots. The generating windings can then exported as a text file and used as a input parameters for the script. Apart from that, it is possible to use this software through API. That means that theoretically it can be integrated into JMAG directly, and it can generate windings without having to save text file, for example. This software can generate such a table with different winding configurations. Here at the top, one can see the pole number, and to the left is the slope number. For a given winding, the program then generates a winding scheme and generates a text report with the winding data and a winding scheme also. This text report, which is that is only a part of it, of the report. That report is then used as a input data for the script. The simplified flowchart of the program looks like that, and we begin with generating of all the windings that are of interest for us, and then save the windings data as text files. Then we feed this text file to the script, which then reads the data and applies the data to a geometry template, which was previously saved or created and then saved, and generates in this way generates the geometry. And in the end, after assigning the winding, the scripts puts out a complete model with correct winding. A few moments of how I implemented this. One can see that this text report that it is being generated by the SWOT EM software has a winding scheme where for every row in the table is a one slot for 2 layers. Yes, I also forgot to mention that the script should also support the implementation of 2-layered windings also. That's why I have here a 2-layered winding as an example, and then mit Hilfe von diesem Code, excuse me, and then with the help of this code, the winding scheme can be transformed to a different format where the values correspond to slot number, and the 3 groups here are phases, and 2 lines are layers, 2 different layers. To then assign these phase numbers. Yes, and of course the minus and plus symbols mean the current direction, which way it goes. after converting the data or the scheme into this format, it can easily be applied to a certain slot, but before we can assign every FAM coil condition or a certain coil condition for every phase to correct slots. We should also numerate the slots accordingly, so that every slot has a number. That way, we can just add a condition where whenever these two numbers are equal, then it means that it is a correct slot and can be assigned to a certain FEM coil condition. This I can explain shortly. For example, here it means that in the slot 1, the phase 1 has positive direction, and in the slot 4, slot 1 has negative direction. One would read it like that. Like I said, this code is for assigning a number to every slot on the circle, going from angle 0 to 3060 with a known angle between the slots, and then the coil conditions are assigned to the renumbered parts or slots or slot conductors. The script can also implement this a multi-phase windings and it means that not only different winding configurations can be tested, but also different phase numbers could be tested, which is a bit complicated to do with existing tools. If one had to test or investigate a fairly large number of different phase numbers or number of phases, and at the same time different number of slots and pole pairs, that would mean that setting these conditions, which I showed here at the beginning, that would take really a lot of time. Because of this, I think that implementing using the script, the scripting feature brings a lot of good here. One thing to mention is that one can see here, it's the formula for the phase shift for different number of phases is different for whether it is for odd or even number. Yeah. Okay. Another reason to my motivation is that I found it difficult to run parametric studies or optimization studies, or just generating various cases for a geometry, while at the same time changing winding configuration. That often breaks the model, and one have to start everything again, setting the conditions and so on. That is another reason why it would be helpful. Now, with that, I'd like to finish my presentation, and if there are any questions, I'd like to answer them.
Vladimir Semin, thank you very much for this presentation. And yes, I have already received questions, and also I think it's more a comment I have received. Quite long comment. I propose to read it, and yes, and then you can see if you want to add something or not. So the comment from Professor Tim Miller. I hope it's okay that this time I mentioned this name, Tim. This is important. The synthesis of windings can be very complex, and there are many irregular or custom windings. The coils are in general all mutually coupled, which means that the winding must not only be imported into JMAG,